In this video, we are gonna solve one fascinating question that will help us to explore different topics on matrix and determinant. The question is this: if matrix A equal to this 3 by 3 matrix and 3A plus 2B the whole transpose equal to A inverse times A transpose, then what is matrix B? This question helps us to learn how to find inverse and transpose of matrix, because this right-hand side expression can only be solved after determining A inverse and A transpose of the given matrix. We will also learn how to multiply two matrices, because we are asked to multiply A inverse and A transpose. The left-hand side expression is about matrix addition, scalar multiplication, and transpose of matrix. So as we proceed to solve the problem, we will explore all these topics. To approach this problem, first let's rewrite matrix B in terms of the product of A inverse and A transpose and matrix A. To take 3A to the right of equality sign, we have to remove this transpose from the left-hand side expression. In part 7 of matrix and determinant series, we have learned that A transpose the whole transpose is equal to matrix A. So to remove the transpose from this left-hand side expression, we have to take the transpose of that same expression. That's 3A plus 2B transpose the whole transpose, because as we see here, transpose of transpose gives us the original matrix. To maintain equality sign, whenever we take transpose of the left-hand side expression, the same has to be applied to the right-hand side expression, meaning 3A plus 2B transpose the whole transpose is equal to A inverse times A transpose the whole transpose. This implies 3A plus 2B transpose the whole transpose gives us 3A plus 2B, transpose cancelled by transpose, which is equal to A inverse times A transpose the whole transpose. Now we can take 3A to the right of equality sign, that's 2B equal to A inverse times A transpose the whole transpose. When we take 3A to the right of equality, it becomes minus 3A. Dividing both sides of equality by the coefficient of matrix B, that's 2, gives us matrix B equal to 1 over 2 times A inverse times A transpose the whole transpose minus 3A. Thus, matrix B is this expression. Now, what we are expected to do is to find A inverse, A transpose, A inverse times A transpose, A inverse times A transpose the whole transpose, and 3A. Let's start with A inverse. We know this general formula. Matrix A times identity matrix is always equal to identity matrix times A inverse. This formula tells us that if we carry out some elementary row operations in order to bring the identity matrix from the right to the left of the multiplication expression, meaning if we can switch these two matrices, the matrix which was at the left and comes to the right will be the inverse of matrix A. To apply this formula, let's form an augmented matrix and set matrix A to the left of the vertical bar and the 3 by 3 identity matrix to the right of the bar. We have to follow a step-by-step approach in order to convert each column of matrix A to the corresponding columns of identity matrix. Let's start with column 1 of the two matrices. This one is similar to this one, and this 0 is similar to this 0, but this negative 1 is different from this 0. To convert this negative 1 to 0, either we have to add it with positive 1 or subtract negative 1 from it. We have positive 1 here in row 1. Thus, to convert this negative 1 to 0, we can add it with this 1. This addition has to apply to all elements of row 3. Thus, the formula that can help us to convert this negative 1 to 0 is row 1 plus row 3. Let's copy row 1 and row 2 elements as they are. Adding row 1 and row 3 elements gives us 1 plus negative 1 is 0. Negative 2 plus negative 2 is negative 4. 3 plus 4 is 7. 1 plus 0 is 1. 0 plus 0 gives us 0. 0 plus 1 gives us 1. When we move to column 2, to convert this negative 2 to 0, we have to add it with positive 2. If we multiply this negative 1 by negative 2, it will give us positive 2. So the formula that can convert this negative 2 to 0 is negative 2 times rho 2 plus rho 1. To convert this negative 1 to positive 1, we have to multiply rho 2 by negative 1. To convert this negative 4 to 0, we can add it with positive 4. To find this positive 4, we have to multiply negative 1 by negative 4. Here, what we did is we multiply rho 2 by negative 4 and add it with rho 3. So the formula that can convert this negative 4 to 0 is negative 4 times rho 2 plus rho 3. Negative 2 times 0 gives us 0. 0 plus 1 is 1. Negative 2 times negative 1 is positive 2. Positive 2 plus negative 2 is 0. Negative 2 times positive 2 is negative 4. Negative 4 plus 3 is negative 1. Negative 2 times 0 is 0. 0 plus 1 gives us 1. Negative 2 times 1 is negative 2. Negative 2 plus 0 is negative 2. Negative 2 times 0 is 0. 0 plus 0 gives us 0. Multiplying row 2 elements by negative 1 gives us 0, 1, negative 2, 0, negative 1, and 0. When we move to row 3, negative 4 times 0 is 0. 0 plus 0 gives us 0. Negative 4 times negative 1 is 4. 4 plus negative 4 gives us 0. Negative 4 times 2 is negative 8. Negative 8 plus 7 gives us negative 1. Negative 4 times 0 is 0. 0 plus 1 is 1. Negative 4 times 1 is negative 4. Negative 4 plus 0 is negative 4. Negative 4 times 0 is 0. 0 plus 1 gives us 1. Finally, we have to convert this column 3 elements to column 3 elements of the identity matrix. To convert these negative 1s to 0, we have to add it with positive 1. If we multiply this negative 1 by negative, we will find positive 1. Thus, the formula that can convert this negative 1 to 0 is negative 1 times rho 3 plus rho 1. Similarly, to convert this negative 2 to 0, we can multiply rho 3 by negative 2 and add it with rho 2. To convert this negative 1 to positive 1, we have to multiply rho 3 by negative. Negative 1 times 0 is 0. 0 plus 1 gives us 1. Negative 1 times 0 is again 0. 0 plus 0 is 0. Negative 1 times negative 1 is positive 1. Positive 1 plus negative 1 is 0. Negative 1 times 1 is negative 1. Negative 1 plus 1 gives us 0. Negative 1 times negative 4 is positive 4. Positive 4 plus negative 2 is positive 2. Negative 1 times 1 is negative 1. Negative 1 plus 0 gives us negative 1. When we move to row 2, negative 2 times 0 is 0. 0 plus 0 gives us 0. Negative 2 times 0 is 0. 0 plus 1 gives us 1. Negative 2 times negative 1 is positive 2. Positive 2 plus negative 2 is 0. Negative 2 times 1 is negative 2. Negative 2 plus 0 is negative 2. Negative 2 times negative 4 is positive 8. Positive 8 plus negative 1 is 7. Negative 2 times 1 is negative 2. Negative 2 plus 0 is negative 2. Multiplying row 3 elements by negative gives us 0, 0, 1, negative 1, 4, and negative 1. As we can see here, the identity matrix comes to the left of the vertical bar. Thus, the matrix to the right of the vertical bar represents the inverse of matrix A. Next, let's find A transpose by exchanging rows and columns of matrix A. Column 1 of matrix A becomes row 1 of A transpose. Column 2 of matrix A becomes row 2 of A transpose. Column 3 of matrix A becomes row 3 of A transpose. At this stage, we found A inverse and A transpose. Hence, we can calculate A inverse times A transpose. Since both of them are 3 by 3 matrices, the multiplication is possible and the product is 3 by 3 matrix. Multiplication of two matrices means the addition of the product of a given row of the first matrix with each column of the second matrix. To find the entry in first row, first column, multiply the first row of A inverse with first column of A transpose. 0 times 1 plus 2 times negative 2 plus negative 1 times 3. To find the element in first row, second column, multiply row 1 of A inverse with column 2 of A transpose, 0 times 0 plus 2 times negative 1 plus negative 1 times 2. To find the entry in first row, third column, multiply row 1 of A inverse with column 3 of A transpose, 0 times negative 1 plus 2 times negative 2 plus negative 1 times 4. To find row 2 column 1 entry, we have to multiply row 2 of A inverse with column 1 of A transpose. Negative 2 times 1 plus 7 times negative 2 plus negative 2 times 3. To find the entry in row 2 column 2, we have to multiply row 2 of A inverse with the corresponding elements of column 2 of A transpose. Negative 2 times 0 plus 7 times negative 1 plus negative 2 times 2. To find the element in row 2 column 3, we have to multiply row 2 of A inverse with the corresponding column 3 elements of A transpose. Negative 2 times negative 1 plus 7 times negative 2 plus negative 2 times 4. To find row 3 column 1 entry, multiply row 3 of A inverse with the corresponding column 1 elements of A transpose. Negative 1 times 1 plus 4 times negative 2 plus negative 1 times 3. By the same analogy, the remaining two elements are negative 1 times 0 plus 4 times negative 1 plus negative 1 times 2 and negative 1 times negative 1 plus 4 times negative 2 plus negative 1 times 4. 0 times 1 is 0 plus negative 2 times 2 is negative 4 plus negative 1 times 3 is negative 3. 0 times 0 is 0 plus 2 times negative 1 is negative 2 plus negative 1 times 2 is negative 2. 0 times negative 1 is 0 plus 2 times negative 2 is negative 4 plus negative 1 times 4 is negative 4. Negative 2 times 1 is negative 2 plus 7 times negative 2 is negative 14 plus negative 2 times 3 is negative 6. Negative 2 times 0 is 0 plus 7 times negative 1 is negative 7 plus negative 2 times 2 is negative 4. Negative 2 times negative 1 is positive 2 plus 7 times negative 2 is negative 14 plus negative 2 times 4 is negative 8. Negative 1 times 1 is negative 1 plus 4 times negative 2 is negative 8 plus negative 1 times 3 is negative 3. Negative 1 times 0 is 0 plus 4 times negative 1 is negative 4 plus negative 1 times 2 is negative 2. Negative 1 times negative 1 is positive 1 plus 4 times negative 2 is negative 8 plus negative 1 times 4 is negative 4. 0 plus negative 4 plus negative 3 is negative 7. 0 plus negative 2 plus negative 2 is negative 4. 0 plus negative 4 plus negative 4 is negative 8. Negative 2 plus negative 14 plus negative 6 is negative 22. 0 plus negative 7 plus negative 4 is negative 11. 2 plus negative 14 plus negative 8 is negative 20. Negative 1 plus negative 8 plus negative 3 is negative 12. 0 plus negative 4 plus negative 2 is negative 6. 1 plus negative 8 plus negative 4 gives us negative 11. Thus, A inverse times A transpose is this 3 by 3 matrix. But our center of interest is to determine the transpose of A inverse times A transpose. We can find that by simply interchanging rows and columns of this matrix. Column 1 of the matrix becomes row 1 of the transpose matrix. Column 2 of the matrix becomes row 2 of the transpose matrix. Column 3 of the matrix becomes row 3 of the transpose matrix. 3A means multiply each element of matrix A by 3. 3 times 1 is 3. 3 times negative 2 is negative 6. 3 times 3 is 9. 3 times 0 is 0. 3 times negative 1 is negative 3. 3 times 2 is 6. 3 times negative 1 is negative 3. 3 times negative 2 is negative 6. 3 times 4 is 12. Now, we found all unknowns of the equation. So we can solve matrix B by subtracting 3A from A inverse times A transpose, the whole transpose, and multiplying the resultant matrix by 1 over 2. That's matrix B equal to 1 over 2 times A inverse times A transpose, the whole transpose is this 3 by 3 matrix, minus 3A means this 3 by 3 matrix, which is equal to 1 over 2 times. Subtracting two matrices means subtracting the corresponding elements of the individual matrix, meaning negative 7 minus 3 is negative 10. Negative 22 minus negative 6 means negative 22 plus 6. Negative 22 plus 6 gives us negative 16. Negative 12 minus 9 gives us negative 21. Negative 4 minus 0 gives us negative 4. Negative 11 minus negative 3 means negative 11 plus 3, which gives us negative 8. Negative 6 minus 6 gives us negative 12. Negative 8 minus negative 3 means negative 8 plus 3, which gives us negative 5. Negative 20 minus negative 6 means negative 20 plus 6, which gives us negative 14. Negative 11 minus 12 gives us negative 23. This 1 over 2 outside the square bracket multiplies each and every element inside the bracket. 1 over 2 times negative 10 gives us negative 5. 1 over 2 times negative 16 gives us negative 8. 1 over 2 times negative 21 gives us negative 21 over 2. 1 over 2 times negative 4 gives us negative 2. 1 over 2 times negative 8 gives us negative 4. 1 over 2 times negative 12 gives us negative 6. 1 over 2 times negative 5 gives us negative 5 over 2. 1 over 2 times negative 14 gives us negative 7. 1 over 2 times negative 23 gives us negative 23 over 2. Hence, matrix B is this 3 by 3 matrix. Hope you enjoy all the explanations and understand the steps we followed. If you have any doubt, don't hesitate to jot down on the comment section. Thank you for your attention. Bye bye.